Hello everyone, welcome to Team AKITA's pitch video for Stage 1, where we inspect the air quality in busy streets in the city of Amsterdam. In this video, we will talk about the EDA, cluster analysis, time series modeling, our results, and discussion. So we were given the data of the amount of air pollutants detected on one of the busiest streets in Amsterdam. Looking at the data, we know that 8 different air pollutants are expected to be detected each time. However, there are missing values. And we chose 3 of the relatively consistent pollutants for our analysis: nitrogen dioxide, PM2.5, and PM10. Next is cluster analysis. To prepare the data, we first drop the missing and negative values, then scale the data, and then use the Abel method to determine the number of clusters. Then we look at the clusters indicating bad air quality. For the worst cluster, we recognize that the majority of the data falls in January. And in this month, the worst air day is the New Year's Day. And then where the hours right after midnight has the worst air quality. This is intuitively the result of fireworks. Looking at the second worst cluster, we found a visually significant difference between the two periods. So our next steps will focus on validating this difference by time series modeling. The objective of our model is that we want to predict 1 hour using the previous 24 hours. We also suspected that this difference may be caused by the citywide lockdown because of the pandemic. Therefore, we determined a cutoff point to separate the data, then examine the effect lockdown has on air quality. After separating the data, we treated the missing values by linear imputation while attaining time consistency, then scaled the data and separated the before lockdown data into training and testing set. We then trained the model using before lockdown data, then predict on the lockdown period, finally compared to the actual values. In other words, we simulated the air pollution during lockdown using before lockdown data, then compared to the actual values during lockdown. While NO2 preserves a more similar behavior, we observe a difference in the particulate matters. This tells us that the citywide lockdown indeed has decreased air pollution in Amsterdam. So lockdown is definitely one factor. The other one is definitely the Clean Air Act of the city. Currently, from 2020, diesel vehicles entering designated low emission zones must have an emission standard of 4 or higher. So on top of that, one thing to consider in order to speed up the emission-free process is a congestion charge, which has been enacted in some major cities in the world and has been quite effective. So we suggest charge the non-emission free vehicles only to encourage clean energy, and then the charge can potentially be increased by a small amount each year until 2030.